Okay, welcome back to the Dublin Academy again. Now today we're going to do logs. Alright, now it's junior higher level maths and it's the junior cycle series 1 and episode 8, and today we're going to do logs. Okay, so these are the questions. Log to the base 3 is equal to 9. Log of 9 to the base 3. Log of 27 to the base 3. Okay, change to index form. Log 64 to the base 4 is equal to 3. Now it's got an equal sign, okay? And then you've got x's, right? Now I'm going to show you how to handle these. First of all, and there's 71, 72, 73, more questions up here. Now, this is a rule in logs. It means that, let's get through the examples. It means that if you have a log of anything to the base of anything, you can change it. You can solve it by making it b is equal to a to the power of c. Did you see what happened here? A came up and c became the power. Now this is what you really need. Okay, now there are a few other rules, but they're not being asked, and I'm not going to go into them, but there's something similar to these, if you get what I mean. Okay, so I'm going to leave that there and we'll have a go at a few questions. So, episode 8. So for example, log to the base of x to the base 4 is equal to 3. X is equal to 4 to the power of 3. Okay, and 4 to the power of 3. Okay, so x is equal to 4 to the power of 3. That's it. Now we'll do another one. Log of 64 to the base 4 is equal to x. Now, what do I do now? Again, I bring them up. 64 is equal to 4 to the power of x, not x to the power of 4. Now we have to solve this. How do we solve it? Same base, again, base. 64 to the power of 4 is, you use your calculator here, you can go 4 to the power of 4, 4 4s are 16, 4 16s are 64, 3 times. See, 4 4s are 16, 4 16s, 64, 3 times is equal to 4 to the power of x, cancel the bases, 3 is equal to x, or x is equal to 3, whichever way you want it, right? Now logs, again, I've noticed, have not turned up a lot, but that doesn't mean they won't turn up. But they will give you the simple form of the questions because they're quite difficult when we get involved. Now we'll just do, we'll do another one. Log of 27 to the base of a third is equal to x. Now, 27 is equal to, bring the third up, a third to the power of x. Now you must follow the routine here, okay? Don't start guessworking, don't start imagining what's going to happen, because imagining doesn't work in maths, it's all logic. You can't be creative in this, only when you're finding out something. Okay, so, if I multiply, I know that if I bring 3, I know that's 1 to the power of anything, 2 is equal to 1. 1 to the power of x is equal to 1, because 1 to the power of big any number is equal to 1. That's the simplicity of it all. And I know if I bring 3 up, it becomes, so I'm not going to deal with 1. It doesn't really bother it. It doesn't bother. And I have to bring the 3. Well, I'll do it like this. That's what it's ended up as. Okay? Now I can bring that up, and I know through my indice rules that I bring that up becomes a minus. 1 over a to the power of m coming up is equal to a to the power of minus n. Okay? Now we've got 27. 3. Now what do I do now? 27 to base 3. What's 3? Because I'm looking at the base 3. And 27 is 3 by 3 by 3. That's 3 times. Not 3 multiplied by. It's 3 times itself. Okay, it's equal to 3 to the power of minus x. Minus x. 3 is it. We cancel the bases. 3 is equal to minus x. It's still not solved. You still got minus x. So you get, just change the signs, x is equal to minus 3, and that's it. And you can see that it is minus 3, you put it in. Okay, right, that's it, very good. X is equal to minus 3. Any other questions? Here we go. Go on. Write down the value of each. Okay. Log 9 base 81 is equal to x. So the question is log of 9 of 81. What's it equal to? Make it equal to x, bring it across, 81 is equal to 9 to the power of x. And then solve it down, get the same base, 81 in the base 3, 9, well you could have 81 as base 9 because 9 fits out, because I know 3 does, but it would be confusing, but you could work it out, you know, it will work, it will be the same. So 9 nines is the same here, 9 to the power of x is equal to 2. Okay, let's try another one. Log to the base 8, log of 64 to the base 8. Now I know it's confusing when you write it. Log to the base 6 of 8, log of 64 to the base 8 is equal to x, right? Because we're bringing in x because we want to solve it. So we don't know what it is. So it might say solve this. Okay, solve. And we introduce an x because we want to solve it. We want to see what it's equal to. Okay, that's the logic of it all. Okay, so log. So I'm bringing this across. And this becomes 64 is equal to 8 to the power of x. And there again, you got 8 8's, 64. Okay, these are quite simple with the 2's in them, right? Too simple. Let's have a look at another one. Change each to the index form. Right, so change to the index form is equal to 2. Yes, the same thing. Sorry, this is equal to x. So it's 25, the same again, is equal to 5 to the power of x, 5 to the power of 2. Right, that's pretty simple again. Right then. Okay, now I'm just going to start introducing the rules. I think that we'll get on and do. So another rule is log of the base a of x over y. So if you have x over y, that's the same as log, same base, x minus log, same base of y. That's what they're telling you. That's a definition. It's a rule. Okay? Another rule is the powered indices. X to the power of y is equal to y times log of a to the power of x. Okay? Anyone else's? Okay, log of 1 to any base, x we'll put in there, any base is equal to 0. Remember that now. Anything so x to the power of 0 is always equal to 1. So in other words, 1 is equal to x to the power of 0, and that is true. We know that through indices. Okay? So remember that. Log of 1 to any base is equal to 0. Right, well, we'll do a few questions. You can freeze these and take these down, you know? So I'm looking at a question here, and there's nothing really, well, here's one here. Log 1 over 27 is equal to x. Now, that means that 1 over 27, this means that 1 over 27 is equal to 3 to the power of x. Now, you know that, let's solve this. So 1 over 27 is 3 to the power of 3 is equal to 3 to the power of x. Bring up to 3 to the power of x. Cancel the bases. X is equal to minus 3, or minus 3 is equal to x. Same principles. Okay? So, let's do another one of these. Let's do another one. Log of 2 to the base of a half is equal to x. And it's the same thing again. 2 is equal to a half to the power of x. Now remember this. Okay, so 2 is equal to 1 over 2 to the power of x. 2 to the power of 1 is equal to 2 to the power of minus x, because 2 is, we'll get to that now, cancel the bases. Minus x is equal to 1, or 1 is equal to minus x, whatever way you're looking at this. Change across the signs. Minus 1 is equal to x, or x is equal to minus 1. Now there's something there I mentioned, I'm trying to get back to it, let me see, no, that seems okay. There's something that jigged my memory there for a bit, I can't remember. Okay, so you got log to base 1, anything else? No. So Okay, I'll just write them down. This x is equal to 1, 1 over 0 is equal to 1. Okay, yeah. So 1 to the power of anything is equal to 1, and 1 to the power of 0 is equal to 1. Now, that's it. That's it for the questions. Right, so there's very little questions on this, that's why I'm rushing through it. But do those questions, they're going to be... so you can solve, see, let's have a look at this one before we go. Well, that's 2 log of x base 2 is equal to 4. Okay, so x is equal to 2 to the power of 4. 2 to the power of 4, 2 2s are 4, 2 4s are 16, 2 16s are 32. Okay, so the answer is x is equal to 32. That's one question I did out for you. Anyway, good luck with this.